Let us consider the basic cos graph, which I like to call the mother graph, because from the cos graph we can derive many other cosine-like graphs. So if you look at the graph here we have labels associated with the graphs, and we notice at 0 degree we have a value of 1, at 90 degree we have a value of 0, and so forth. So on the next page we will look at the period and the amplitude, etc. So let us look at the period. We can start anywhere. We can start at B, go up to C, down to D, up, down to E, and again up to F, and then we get a new part that's exactly the same as from B to C. Or we can just start at C, and then we have sort of a cup-like shape, which is defined from 0 to 360 degrees. So once we have a piece like this, we can just again make a stencil and draw the whole graph from minus infinity to plus infinity. So let's look at the period. When we look at any point on the graph, as we've seen with the sine graph, then we just look and see when we do find the same shape again forming from there onwards. And we can start at C and then go down to D, E, and up to F again to G, and we have sort of a cup-like shape here, which is the whole cycle of cos graph, and that happens from 0 to 360 degrees, and we have our period of 360 degrees. We can also look at the amplitude, which is the maximum divided by a minimum. We notice at C we have a maximum at 1, and we have a minimum here at E, which is -1. If we all divide it by 2, we get a value of 1 back. If we look at the roots, then we actually want to solve where is cos theta equal to 0, and to do that I can just look at these points here. We notice at B and at D and at F the graph will cross the horizontal axis, so the intercepts with the horizontal axis happens at -90 degrees, at plus 90 degrees, and then at 270 degrees, and so forth. In general, we can write down the roots by taking any value, like for instance 90 degrees, and then we can just add 180 degrees times k to get to the next value. So if k is an element of z. So let's see, if I make k 1, let us make k 0 first. If k is 0, then most definitely we will get to point D. If we make k equal to 1, we will get 180 plus 90, which is 270. If we make k equal to -1, we will get back to -90 degrees. We can also write this theta value. We can also write theta as 2k plus 1 times 90 degrees, where k is an element of z. That's another way to write it. We just take out 90 as a common factor, and then we have a value there. So this 2k plus 1 tells us that at all the odd numbers we will have multiples of 90 degrees, like 4 at 1, at 3, at 5, etc. The extremes are plus 1 and -1, and they occur at, in this case, the minima occurs at A and at E, and the maxima occurs at C and at G, and also if we extend the interval there will be many more. So to find the minima, we can start at the horizontal value, in other words at -180 degrees, so it's again a theta, is minus 180 degrees. And then to get to the next minima, we need to add 360 degrees times k. For the maxima, we can take the point C, which is 0 degrees. And then we need to add k times 360 degrees, where k is an element of z. On the next page, I've just made a summary of these facts. So this page just provide a neat summary of what we said on the previous page, and you can keep this page or make a print out of it so that you can have it as a future reference.